All right, so I think this is recording. Let's solve this absolute value inequality. When we look at it on the right-hand side, we see two terms, and the term of interest is the one that contains our absolute value. Um, so let's get this term by itself. All right, so let's add 4 to each side. 46 plus 4 is 50. 50 is less than or equal to 10 times this absolute value. So I want it now on the right hand side. I have two factors, and the factor of interest is the one that has our absolute value. We need to get that by itself, so we need to undo this multiplication. So I'm going to divide both sides by positive 10, and that does not change the direction of the inequality. So I have 5 is less than or equal to x minus 4. And it just, I have a preference. You can leave it like that. I have a preference towards having my expressions, my variable expressions on the left. Now the arrow is pointing towards 5. It's still pointing towards 5. You know, to say that 5 is smaller than the absolute value of this expression is the same thing as saying the absolute value of this expression is greater than 5. All right, so when the arrow is pointing away from the absolute value, I know that absolute value is a distance from 0. So I know that I'm greater than 5 units away from 0, possibly a lot greater. So if I make a sketch on a number line to help me split this inequality into two inequalities, if here's 0, if I'm 5 units away, I might be to the right or to the left, and since it's underlined, we might be exactly 5 units. But we could be more than 5 units away, and more than 5 units away, like 6, 7, and things like that, are shaded, what I call out in the tails of the number line. You'll hear me use that phrase a lot. So when the arrow is pointing away from the absolute value, I'm away from the middle. That tells me how to set up my two inequalities, that this x minus 4 might be less than or equal to negative 5, or this x minus 4, its distance is more than 5 units away from 0. All right, so let's solve for x. Let's add positive 4 to each side. We have x is less than or equal to negative 1. I lost my or statement. Let's add 4 to each side, or x is greater than or equal to 9. See, my first sketch was not a sketch of my solution set. It was just a sketch to help me with the expression that's inside the absolute value. Now, I have two inequalities that describes my solution set. And if I want a picture of that solution set, I can make a graph. And negative 1 is to the left of positive 9 on a number line. Since each of these, it's underlined, each of these has equality, and I make these endpoints solid dots. For x to be less than negative 1, less than or equal to, I shaded that in. You're to the left of negative 1, so I shade to the, with my variable on the left, the arrow is pointing in the direction that I shade. X greater than or equal to 9, I've already included 9, and to be greater than 9 is to the right of 9, so the arrow is pointing in the direction that I shade. All right, so this is my final answer, and then this is a graph, a picture of that final answer of that solution set. All right, well, I hope that helps, and I will talk to you later. Don't be afraid to ask questions. Bye.